That'll be rude.
Testing 1, 2, 3.
Testing 1, 2, 3. Testing 1, 2, 3.
Testing. 1, 2, 3. Loud and clear. My turn face down.
Hello. Hello, everyone. Hi. Hi. I guess we are ready. So first of all, thank you everyone for attending this month's ML Tech Talks event. For those of you attending for the first time, this is something we do every month where we try to get people either interested in or working in the area of machine learning together, share and discuss a few topics. And in the long term, we hope to build a local community of like-minded people here in Taiwan, or at least in Taipei. Now, a few points about the logistics. There's food and drinks here, so please feel free to grab anything you want to eat or drink. Washroom is outside. If you exit and walk towards the stairs, it's right next to the stairs. Please remember to use the outdoor slippers if you want to use the washroom. And the next thing is I just want to understand the audience a bit more. So a quick show of hands. How many of you are students doing undergrad or grad or maybe even PhD? Okay, around 3 or 4. And how many of you are working in the area of machine learning? All right, like 7 or 8. And I guess the rest of you. All right, yeah, I'm going to that. Yeah, so last but not the least, a quick introduction of our speakers tonight. So we have 2 speakers tonight. Our first speaker is Dar-Yen from PicCollage, and he'll be talking about style transfer in text to image. Tell Dalí a story, ask him to paint it for you. And our second speaker is Moritz, and his topic is LLMs for text mining, a case study on Taiwanese e-participation platforms. So without further ado, let's welcome Dar-Yen.
Hello everyone. Welcome here. So, topic of is style transfer in text to image.
Try again.
Hello. Okay, it's working. So the topic will be style transfer in text to image. And so in the right, we can see the persistent memory, one of the favorite artwork of Dalí. And in the following section, we'll try to use this as a style reference and to see if we can have some interesting results. So first, we'll talk about what text to image style transfer is, and then we'll mention the challenges in current T2I style transfers, and our highlight will be the recent research in PicCollage. It's an eco art adapter. It's aimed to alleviate the challenge we'll mention. Yeah. So first of all, what's T2I style transfers? So we all know the T2I generating. We feed a prompt into a model, and we wish the model can generate some results that are aligning with our prompt to have some appealing results. So if we want the result to have some very specific style, then we can provide a style reference to the models. Then we hope again, then the model can generate results that align with the style we provided. So how we can provide a style? It can be provided by text, or we can provide it by a style reference. So the T2I style transfer is, we can build it at 2 aspects. The first of all is the style. We can have a style from a style reference. It can be a single image, like a famous artwork. We have a persistent memory, or it can be the Starry of Night, the Mona Lisa, or it can be a collection of paintings. It can be like, again, a collection of painting of Van Gogh, Monet, or any artworks, or anything. It just need to have a unique style, right? So, and the second thing is same with the T2I generating. If we need a content, and the content should come from the text prompt, we need to textual control the results. So in the right, we have some example of T2I style transfer using the persistent memories. I use 2 prompts, lighthouse during a storm and a vintage car. From this result, we can observe some style features from the persistence of memory, like the color, the brushstroke, and the surrealism, composition, and maybe the distortion about the car. Yeah. So why not just use prompt engineering? So the problem is that sometimes style is hard to describe in text. Right? We can hard to describe the abstraction of the artwork, or the brushstroke, or the compositions, like to a certain degree, or the very distinctive or unique features. And if we're lucky enough that our style reference come from a very famous artist like Dalí or Van Gogh's, then it probably be learned by the model in the training data, right? So if we feed the prompt of Dalí as a condition into a model, then the model will better capture the style feature of what we want since it learned it, but they still have a problem. Like the first case is it will select it, one of the artwork as a reference. It probably will be the most famous one. So if the artist is maybe Van Gogh, then probably will be the Starry Night. If we choose Da Vinci, then it probably will be the Mona Lisa. And the second case is it will try to blend in several artwork of the artist or the name you provided. And so in the result, you can find a hint of a lot of artwork, but it's still undesirable. We want a very specific style as in the style reference we provided. Yeah, so in the right, I use Dalí 3 and ChatGPT 4 to generate some result using the same prompt. And we can see like it's hard to capture the style feature from the system memory. We can still find a distortion, and we can even find the clock to replace the tire in the car. But it's hard to say it's authentic to the persistence of memory. So the core of the T2I style transfer is the authentic style representation. Overall, it's called style transfer, right? And the second thing is when the model can provide an authentic style transfer, we want it still aligned with the prompt we give. Otherwise, it has no meaning. Right? We want to generate results as we want. We want to control the results. So for the existing T2I style transfer models, we have two major problems. First of all, is the most significant one is that the result will usually dominated by the content structure from the style reference. It means that the content will not be decided by the prompt, by the style reference. So the prompt will be ignored. We lose the control. And the second thing is for some method need fine tuning like string boost or the textual inversion. It needs like dozens of minutes in the inference time fine tunings for a new style. Sometimes it's just too time consuming. We want the little short models or even a fast fine tuning to reduce the time we need for a new style. It will be let the T2I style transfer more flexible. So to alleviate this, we have a research on how to solve this challenge. So we can talk about architecture briefly. So in most of the work of diffusion-based T2I style transfers, the first thing we need to do is to extract the style features. In most work, they use a transformer architecture like Clip or Dino VIT, something like that to extract the style. But the problem is that within this feature, the feature of these transformers usually carry a lot of information from the content, and it's hard to eliminate. So it will result in the issue we mentioned that the content will leakage into a result. And so in here, we choose another network that is VGG. And actually, VG is quite a classic choice in style transfer to calculating the style similarity by using its statistics like mean and standard deviation or the grid metric. The second order static is known for its do not carry the content structure information, and it can capture the style feature. So we use it as to help to extract the style features, and then after we choose 3 activation to represent the low, mid, and high levels features, and after the style encoder, we can get a style embedding. Here is written by F. Actually, we can view it as a pseudo word that describe the style. So it will be concatenated with the text words. Like here is a robot. So it will be content together, and for the text encoder, the style can have a chance to interact with the theme, just as what text encoder do. Yeah. So after that, we, as usual, we use cross attention to condition on the style embeddings, and very specifically, we apply adaptations, but we only apply adaptation on the style entries. It means that, as we can see here, only the projection of the style embedding is trainable, while the projection of others entries, like for the text, here's a robot, is frozen. So the attention will only apply on the style, and remaining the already trained very well projection of text as frozen. So we will not face we don't need to worry to destruct the generalizability of the pre-trained model, and the attention can focus on the unfamiliar style, which the model really need to learn, but not other concept. Okay, cool. And beside this, another component of here is the auxiliary content adapters. The idea is, since we all know the diffusion model is actually a self-reconstruction task, so you need to, during reconstruction, you need the content information and style information from a style reference, then it can have a chance to reconstruct itself. So we split the style and content into two components. So the style encoder and the adaptation will focus on the style, while the content will be taken responsible by the auxiliary content adapters. It will provide a content structure to the unit model during the training, and let other component can focus on capturing style. So during inference, once we discard the content adapter, the content information have no chance to influence the results. So we can greatly alleviate the problem we've mentioned, that the content will leakage from the style reference to a result. In our structure, this road, since the content data will be discarded, inference will be alleviated. Yeah, so here's some results of our models. We can see actually the girl is quite a most tricky one here. I think it's a very clean face. It poses a challenge on the T2I style transfer, as we mentioned, since in conventional, the face will usually appear in the results, since it's a really clean content structure. And we can see in our result, we cannot see the face in the result, and it's still aligned with the prompt. It's for penguin or for lighthouse or any others. We keep the diversity of the model and can be general to diverse contexts. Yeah, we can use the results. We can for different style, from famous artwork to something static painting here. Yeah. So here we can have some ablation on our component. The most important thing, I think, is the center color. Then the third column. In the second column is our little short result. It means that we don't need any fine tuning during inference, and we can capture the style feature in very, I think it's quite authentic. And we can see that if we train without the auxiliary content adapter, then the face from Mona Lisa will appear in the results. It's what we mentioned, the content leakage from the style reference, right? So when we disentangle the content and style during training and discard the content component in inference, we can greatly eliminate the content in the results. Yeah. And the last two columns is the study about how each adaptation to help capture more delicate, or you can say more details style features. Yeah. So we can recall the style, the multi-level style encoder here. So we can generate style embedding in 3 levels: the low, mid, and high level, right? So if we use different style to generate this style embedding, like one for a low level, one for a mid level, and one for a high level, then we can mix the style together, and each will provide the feature in the corresponding levels. So here we show a result of mixing 2 styles, one for the low and mid level, and one for the high level. So we can see what happened. So actually, the low and mid levels will provide a feature about the color, the tone, and the brushstroke, the some texture. Like we can see the Mona Lisa's, the yellowish and some vague texture, and maybe the third row is you can see some impressionism tone. Yeah. And for the high level, you will decide the composition and make some high level art concept of the work. Yeah. So it's very interesting to observe how style mixing together and how each level's features to affect the results. Yeah, so we're back to our subtitle, Tell Dalí the story, asking to painting for you. So here, actually, I use about 5 words to describe a short story and let the model to generate the results to me. So the first one is a Voldemort. Yeah, and the second one is a Romeo and Juliet, and the third one is a Little Red Riding Hood. Actually, it's not really good. It's actually not Red Hoodie, right? But yeah, but I just love the wolf in the background. I think it's more dramatic, so I choose this one, even it's not even red. Yeah. Something. Yeah, so in the end, we can view a demo video of our work together. Yeah. Sorry about it. So thanks for listening. That's it. If you are interested with our research, you can view the project page here.
Should we do some Q&A? We'll do a few, like maybe 5 minutes Q&A now, but I know it's always a little bit intimidating to ask questions straight away. So maybe talk to the person next to you. You've got a question straight away? Awesome. Okay, I'm coming over. Yeah, you can just speak to that.
Hi. Yeah, thanks for the talk. It was really interesting. maybe I didn't catch that, but in this whole architecture, is there, which part is it the one that you are training or fine tuning, or no, you're not relying on that, are you? So each of these images that you've generated just now in the video, they're not necessarily, they're just inferenced, right? They're not actually, you're not training anything. Just providing a style, and then you're relying on the encoder to help you with the diffusion, is it?
You can use. Sorry. Oh,
here. Actually, our model can apply the visual shading, like you say, it can be applied without fine tuning. But if we saw some fast fine tuning with about 1 minute to take about 25 steps, it can have better results. So here results are with fine tuning, and here. So here the visual shot means without fine tuning, but with some fine tuning it will better, and it can greatly avoid overfitting. So even with fine tuning, we don't need to worry about overfitting happen even with a single reference image. And we all know that for some famous artwork, you have to find a second one. So for a single image, fine tuning is really important. And since the time is not enough, but if you're interested, you can watch a paper. You can there's more detail in there.
Okay, thanks.
Thanks.
anybody else? There's a question over here. Yeah.
Hi. So a lot of artists, when they start their work, they also have, like, first of all, they're in a certain time frame, like things in society are happening, things in their personal life, maybe the artist is in love. And so my question is there a chance to bring in some like subjective emotional experience, or like, for example, that we say, like, not only use a style, but also integrate certain emotions, like, for example, to be in love or to be in stress, or that there are certain things in society are happening. So the idea, that's an idea, of course, also for your product. It's also a question.
It's a really great idea, and I never think about that. And yes, I would say it's I think it would be separated into two parts. Like for a text to image generating, you have a text part, and then for a computer vision part. For emotion and, like you say, the personal life experience, I think it's quite interesting. And if we can improve the language part, like for the clip, or to have better model like Dalí 3, using a ChatGPT can be better to try to involve this more abstract concept into the artwork, into the final result. But I think it's really interesting. Yes. Currently for this project and for the computer vision part, it's try to capture the visual, try to capture the vision feature. Yeah. Thanks for your question. Yeah, I will think about that.
Well, there's people online who want to hear your excellent question as well, I think.
Thank you. Yeah, I'm curious more into in the training part.
Yeah.
So when you have a reference and the sentence for the story, how you train the model? So because I saw that it's really fit to the every object. So like the color, it's really well distributed to the object. So it's not going to be just fit the pattern of the color, but it distribute well too. So yeah, did you train a certain pattern of the image, like you train human or animal, or plants, or do you train like a barrier of the angle, the edge of the object? So yeah, so it can recognize the edge of the object, something like.
We train our backbone, the other data backbone, on the Leon aesthetic data set. It's actually a Leon data set, but with the aesthetic score higher than, I think it's 0.65, something like that. And the WikiR data set, which is a collection of a lot of artworks. And we can. Yeah, so for actually within this data set, there's a lot of artworks and some image with high aesthetics score. Actually, it's automatic generate, but it's quite beautiful. Yes. So training on this data set, the model can have chance to capture these very appealing features, and we can look back to the training process. Like here, you mentioned the colors. So one thing I can mention more is about we apply the color augmentation here for the content adapter. Since we don't want the content adapter to learning the color, right? The color should belong to the style. So here our method is to apply color augmentation. So the content adapter is hard to apply. It's hard to provide the color information to the diffusion backbone. So the diffusion backbone need to learn the style feature from the style component. In here is the style encoder and adaptation.
I see. Yeah, thank you.
Thanks.
Yeah, this is really interesting, and just curious because like ChatGPT also can draw the image if we tell something like the keyword to show the image. So maybe is the principle of the creating image is the same with this or different? I'm just curious if the ChatGPT background.
Sorry?
Yeah, ChatGPT, it can draw the image.
Yeah.
So this is also draw the image. Can it, right?
Yeah.
So it's like the same principle.
The ChatGPT is here. Actually, the ChatGPT you study to is kind of prompt engineering. Like you provide the stuff, you can provide image or any prompt. You will use a ChatGPT 4 to output a prompt, and then use a prompt in the T2I model, then generate image. And here the difference is that the model take the style reference, the image condition, as a condition directly rather than just a text prompt. Yeah. It's a difference.
Okay. It sounds like there's lots of questions. So we'll in a couple of minutes we'll go for a breakout. Before we do, my colleague Morgan would just like to see if there's any interest in the audience.
Okay. Hello everyone. I'm Morgan. I'm the product designer in PicCollage, and I would like to share a recent opening position in PicCollage product design team, which is the AIPD, the AI product designer. So what exactly will this role be doing? We hope this role to focusing on the AI related project like style transfer or any other potential AI related product in PicCollage. And also we hope this role to collaborate closely with our amazing ML engineers to discuss and maybe optimize the results. So besides the designing the UI UX of the application, we also hope this role to involve more in the AI part as well, and also help shaping the AI products for PicCollage from the designer's perspective. So I understand that most of the people here today are engineers, but if you're a designer who has relevant experience or interest, feel free to talk to me later. And if you also know someone who may be suitable for this role, welcome to share this info to your friends. Thank you.
Okay, cool. We'll have 10 minutes breakout. Talk to the people around you about the sharing you just saw, or if you want to apply for a job. Otherwise, we'll come back in about 10 minutes for Moritz's sharing. Okay, thank you. Eat some food and enjoy yourselves. Moritz, where are you? I'll turn the music on.
Okay.
Is that working? I think that one's working okay.
Yeah.
Too.
Should work.
Yeah, this is working. Everyone can hear us. Vinay, you can hear us at the back. Yeah, good. Okay. Okay. So yeah, Moritz is our kind of special guest speaker for today, and I'll let him introduce the talk beyond me, but hopefully it's going to be relevant for all of you. So without further ado, over to you.
Sweet. Thanks, Lawrence. Yeah, I'll talk about LLMs for text mining today on like a database from Taiwan. And yeah, you can see Llama 2 made it to Taiwan. Yeah. So that's just the brief overview. And let's start right with what is this all about. So basically we analyze e-participation platforms, and they are like participation platforms for everyone just like us, where you can go and make a proposal and people can vote for it. And then policy makers should take these proposals into account if they pass a certain threshold. So this is not only happening in Taiwan, there's also, I think, in the US, something like We the People, which was introduced by Obama. And yeah, in Taiwan, there's two big ones, which are called Join and iVoting. And yeah, basically we kind of conducting some research, and we thought maybe from these platforms we can read out some events. For example, if we could read out what happened in Taiwan, like what kind of events happened here. As for example, pedestrian help, which was an event, I think, this year or in spring or last year, I kind of forgot. But yeah, it's like where a pedestrian got hit by an SUV, and there was a big outrage from the citizens, and they all like complain, like that the streets are not safe. And yeah, so we thought maybe we can read out something from or these events then influence people to make some proposals on the platform. So, and then what are some challenges that we encounter is like basically all the data is in Chinese. But yeah, I've been here quite some time, but my Chinese is not good enough to read and understand it. So, we switch?
It happened.
All right, okay. Yeah, new mic. So yeah, and then yeah, we translate it to English. So there's also there might be some information getting lost there, and yeah, that's some of the challenges. And of course, it's the data set we looked at is huge. Like, so two data sets in fact, like iJoin and iVoting. So they all contain features like the publication date, the URL, the title, the proposal itself, benefits, impacts of the proposal, the number of votes that the proposal received, the minimum votes necessary for the proposal, then the submission date, and how many followers it had, and who was the proposer. So for Join, it's like 14,000 samples. So it's quite a massive data set. And to read it all one by one, since one proposal is quite a bit of a text. And the iVoting platform has like 400 samples. So Join is Taiwan-wide, and iVoting is more focused on Taipei. But yeah, and here you can see basically the whole text corpus kind of compressed. Yeah. Oh, and we scrape the data from the web. Yeah. So this is how one single observation looks like. So I guess some people can read it, some people cannot. So that's the translation basically, and yeah, that's what we work with mostly. And this proposal was, for example,
about increasing the penalty of cruelty to animals in the animal protection law, which we later talk about again. And this is the observation time frame. So we started collecting from 2015 to 2022. And there's like a small variation in proposals submitted of each year. And this is the monthly observations or monthly proposals. And then just for fun, I actually also looked in what are the most voted proposals. And one you just saw is the increase the penalty of cruelty to animals in the animal protection law. So people in Taiwan really love animals. And number 2 is something about taxes, because nobody can evade taxes. Right? And number 3 is about medical violence and criminal law punishments for drunk driving. It's also a big topic in this platform, and something about childcare. Yeah, and then actually we also thought, okay, there's maybe some top proposals that might occur, and maybe those proposals have more votes than others, but like you can see, some people made up to 94 proposals over the observation time frame. But in fact, actually the people who got the most votes only had a few proposals. So, and how did we basically analyze the data? So that was all about the data, but since we are machine learning Meetup, you guys are interested how we analyze it with what kind of methods. So we use something called bird topic. And this is how it looks like. Basically, it's like a very modular approach. So we first need to create our embeddings at the very low level. So take the text and put it inside embedded space. So then you get your embedding vector, which is very high dimensional. So to further work with it, you can apply some dimensionality reduction method. And then you cluster it, and you tokenize it, and you weight your wordings, and then you can fine-tune your representation. So basically, you can play around with all these like modules, then you can build your own Lego cube. So that's what we did, and this is what we ended up with. So we take the embeddings, which are from Beijing Association of AI, and they have a really good embedding model, which is like top 3 under the recent benchmark for LLM embeddings. And then we use those embeddings and reduce it with UMAP, so uniform manifold approximation and projection. And then we do some high density based spatial clustering for applications with noise. And then we do the term frequency, inverse document frequency for filtering out the most important terms, and feed those terms into Llama 2, like 50 billions, which is more provided by Meta. So basically, we're just using this architecture in the middle, but I don't want to go into too much detail. I guess most of you might be familiar, I guess. Just the normal attention mechanism, or like normal transform. And this is how UMAP looks like. So you can see it's kind of like the TSNE, which is another like stochastic neighborhood estimate, just another projection method. So basically, you can see that those images have been projected into a 3-dimensional space. And then cluster. But the better thing about UMAP actually is it kind of better in preserving global structure than TSNE. So and kind of work well for our method. And then the HDD scan is the clustering method that we use. So it can be the basic intuition is that you want to cluster points that are close together, and then you kind of think these are like islands in a sea, and the sea is basically the noise. So first we need to estimate the density, and then we can from there when if you lower the sea level, basically you can create a hierarchy. And yeah, how this measure is done, how it is with a measure called like core distance. So basically the core distance is the distance to your kth nearest neighbor. And then when you can calculate the core distance for each of those embedding points. And then with this measure, you can then create a mutual reachability distance, which is basically the maximum of your core distances of those 2 points and the distance of those 2 points. So basically, the core distance or the mutual reachability distance of green and blue would be the core distance of the green one, because it's the longest distance. Like it's longer than the distance between the 2 points, also bigger than the core distance of the blue point. Exactly. And then basically you can then create a graph between all your points in space, and each edge between those points is the mutual reachability distance. And then you can start forming your clusters by having a threshold above which you only take the edges, and all edges below the threshold, they will be not considered. And then you can get your clusters. So, okay, that's about the method. And then basically the technical setup that we use is like a GeForce 4080 RTX and Intel Core i7 processor, 46 GB of RAM, and yeah, Ubuntu as operations. And yeah, what did we basically see from all this data on, you might wonder. So this is basically the whole data set visualized. So you can see, like now we have, these are all the topics that we extracted from these 40,000 samples. Is it good visual? Yeah. Okay. So big topic was like education policies in Taiwan, then government response to COVID-19 epidemic, labor rights, regulations, criminal justice reform, traffic safety regulations. And you can always see like one point is one proposal. And so the bigger the island, so to say, the more proposals, or maybe also the wider, I mean, the more points basically. Yeah, energy transition and sustainable development, then tobacco control and smoking regulations also point, and animal welfare is also one of the clusters, and the political status of Taiwan and its relationship with China also big topic in this one of the clusters. Then the gender and military service, and yeah, electoral reform, and media regulation, false information on it. So keep in mind these are all like created with Llama 2, and like so sometimes, for example, gender and military service sounds a little bit weird, I think, but basically we can understand what's inside this cluster. Sorry, it's sorry, okay. Yeah, okay, good. For me, it sounds a little weird, but yeah, I'm not Taiwanese, so I can't say. So great, and then actually what we also did is, you can see on the left just the image from before. Then we also looked at which proposals got passed. So after clustering, you can see that there were a lot of proposals, but only very few have been passed. And actually, my friend, like another collaborator who's here today as well, he's from like traffic safety regulations, and he will look into like these past proposals and do evaluate qualitatively what has happened to these proposals. And then we did the same for join, but it's a little bit smaller. So, but the topics kind of overlap. So there's again traffic safety regulations, big housing market, energy transition, sustainable development, tobacco control again, animal welfare, and political status. Yeah, and basically this is the histogram, so how many proposals in each of those clusters. Okay, and so sorry, this is the next platform. So this is before, sorry, that is the next platform. So iVoting is the Taipei-wide platform. So those proposals are all about policies in Taipei. So you can see there's like Taipei public transportation, also traffic management, waste management and recycling in Taiwan, then Taiwan's epidemic prevention reports, education, labor and social welfare, and public servant conduct and accountability. And this is again the histogram for those topics. So basically, this is the governments and sustainability in Taiwan, and traffic management, then Taipei, public transportation, education, and so on. And then actually what's also quite nice about this, we can look at topics over time and then look at the chronology. What happened, for example, I think since we're all familiar with it, like in 2020, proposals for like COVID-19 medical response like skyrocketed. So you can see like it wasn't there at all previously. And then over 2020, we can suddenly see there's an increase from 0 to 100 proposals within 1 year or within 1 or 2 months. Yeah. So basically that also validates our approach. Like since we can obviously we know that COVID hit like in 2019, 2020, like end of 2019, starting 2020. So we can basically see that the happenings on the platform are basically also represented in reality. And the same thing for iVoting. And then actually these are the topic words scores for each of the topics for the joint platform. So you can see the topics that you just seen, for example, traffic safety regulations, like the words, top 10 words in there is like driving, traffic, road, car, vehicles, license, speed, driver, drunk, and vehicle. And the number represents the probability of the word in the document according to the term frequency, inverse document frequency. And the same for iVoting. And then actually another cool thing about word topic, actually this is the framework that we use depending on how you do your clustering and the hierarchy. You can even go very fine-grained, and you can see that this is now with very small cluster size, or basically this is with a different HTTP scan. So before you have seen HTTP scan with 15 topics of 14 clusters, but now we actually changed it to having more clusters. And you can see those finer clusters like tall snow jams is one cluster, but I don't know what happened because in Taiwan usually there's not so much snow, like, or speed overtaking inner or locomotives, heavy 550cc. So that's about like engine volume. And Uber is also a topic, and driver license stage, and the age for motorcycle 60s. So these are all topics that we cluster. And then one more thing, if you go very deep, very fine with the clusters, you could also again see things like Uber hitting Taiwanese market. That was 2019 when Uber kind of hit Taiwanese market, and probably cab drivers like went to the platform and complained about, or like made a proposal about these specifically Uber. Yeah. And then actually evaluated our method also. And we labeled like a small data set, about 110 samples, and then we gave it labels that we thought were appropriate, and compared it with the labels that the LLM gave it. And yeah, it's a bit difficult because I'm sure everyone who will read a proposal will give it a different topic. So even the LLM give it a different topic than I would, you might still be correct, right? So it's taken with a little bit of a grain of salt, but yeah, we feel like 80% or something of the topics is quite well labeled, and 12 are definitely wrongly classified, and for 8 we're like not so sure it's correct, or yeah, it's a little bit about if you could ask the LLM, you could make sure it can, right? So yeah, this is about what the topics that we thought in the beginning were the topics that are inside the text corpus, but in the end, the LLM gave it a different topic model, and yeah. And then you might have seen there was an inappropriate content topic. So and then these were all the classes with information that was not appropriate due to leakage of personal information, which is prohibited on those platforms. So maybe, yeah, what to take home, or so kind of what are the topics we discussed on participation platforms, and kind of gave an insight today. And yeah, how do the political event influence proposals? So actually those platforms can be used also to see what's happening in the real world and vice versa. And there's probably not certain political influences. And we are still looking into what happens to the proposals after they have been passed on the platforms in the future. Like there's no data bench online, like we were trying to look for a database that lists all the laws that have been passed in Taiwan, but there's no such thing. So we have to evaluate some like qualitative study for that. And yeah, actually we still have like one thing that we want to propose for comparing like, the original Chinese with the English topic modeling. That's also something we want to look into in the future. Like, does the Chinese LLM come up with a different topic model than an English one would do? And how are those topics like related? And yeah, this is basically my contributors. So I'm actually still a university student, also working but part-time. And my collaborators, Jonas, is here tonight. So he was helping me a lot. And he's basically doing the qualitative studies for the urban development part. So yeah, if you want to contact me or anytime, yeah, feel free to message me or reach out in GitHub or wherever. So then, thanks for your attention, and that's it.
Questions?
Questions? Yeah, very Vinesh. No mics here.
Shout or come over. Yeah.
So my my question was there any sort of analysis to find out how diverse in the sense of agreeable or disagreeable the proposals were in a given cluster? For example, I could assume that for traffic, most proposals would be like in one direction, like it would be agreeable, like you want something better for the streams, but maybe for something like COVID, people might have very opposing opinions. So I'm just wondering if there was some analysis about the diversity of proposals in cluster.
Inside classes, actually, the only thing we have is basically right now the kind of distance or like how wide the cluster spread, kind of giving information about how diverse those.
So the width corresponds to diversity.
In a certain way, right? Like those proposals are closer together in the embedding space or in the projection space, right? So, but we haven't specifically measured intra-cluster distance.
Yeah.
Yeah, but it's a good point. Maybe it has something to do in the future.
Yeah, I also had a question about the clustering. So some of the points are like colored by the category they belong to, but they are actually like in the middle of another cluster. Like what are like some example of like maybe how did you handle these outliers and what do they represent actually here?
Yes, like are you talking about this one or here, this yellow thing here? I'm not sure. Or the green ones, I mean, like what we did is of course, actually it's a bit difficult to cluster everything to one, we kind of hard cluster everything. Like we always look which is the highest likely cluster something belongs to, but for sure, one proposal can actually hit 2 classes, right? We should. So yeah, but what we did is just we look at the highest probability for 1 classes according to the representation of the words inside this document.
So in the proposal, do they also like give it like a category of what the proposal is about, or you really find it out by the text itself?
Exactly. Actually, this is all unsupervised machine learning. So the only labels that we have is the 110 labels that we created. So basically, there's no given category from the platform. But unfortunately, I would also like to have some labels.
Maybe a bit more technical.
Sure.
But so when I saw basically the steps called from text to embedding plus for the TF-IDF and all these things, are you using the same tokenizer as down? Like what kind of tokenizer are you using for those? Or just
Like this, wait, you mean this tokenizer, right? So it's not the tokenizer for the LLM. It's a tokenizer for the making the vector into terms, like into words. Yeah.
Yeah. So
Basically.
is it still you're just using like a space tokenizer or?
Yeah, we are using count vectorizer. So basically, how often word occurs in the document.
What I'm trying to get is different embedding models that come with their own tokenizer, like they're trained.
Yeah.
Or they're different tokens. Are you using a pre-trained tokenizer or?
Like, actually, it's a bit confusing. This tokenizer is not a tokenizer for the LLM. The LLM has used the LLM tokenizer. So, for example, in our case, we use the tokenizer for BAE. Then we create the vector embeddings, and basically then we compare the documents. Then for each document, we create a count vectorizer. So basically saying how often this term occurs, and we have on this vector how many times each word occurs. Yeah. So, okay. Yeah, thanks for the question.
Cool. You can breathe. Good job. Okay. It sounds like there's probably more discussions that could continue. So we've got like another 20, 25 minutes to hang around. I think there's still some pizzas left, there's some food. I want to thank everybody again for coming. And I think this is our 6th machine learning tech talk. We've had, I guess, 12 people sharing, and we're always looking for more people to come up and share research, anything they're working on. So yeah, contact me or Vinay, anybody you know working here at PicCollage if you want to contribute to this. Otherwise, enjoy the evening and hopefully see you next time. All right, thank you.
Yeah.